Understand how to read a potential energy curve for a covalent bond. X-axis position of the minimum, while represents the equilibrium bond length, the internuclear distance at which the molecule is most stable. A minimum located further to the left indicates a shorter bond length. Y-axis depth of the minimum, while represents the bond dissociation energy, the energy required to break the bond. A deeper well, more negative potential energy, indicates a stronger bond with higher bond energy. Analyze the physical properties of the three molecules, H2, N2, O2 atomic radii and sizes. Hydrogen, H, is a period 1 element with only a 1s electron shell, making it exceptionally small. Nitrogen, N, and oxygen, O, are period 2 elements with N equals 2 valence shells. Because hydrogen atoms are so small, the HH bond length is significantly shorter than both the NN and OO bond lengths. Bond order and bond strength. H2 contains a single covalent bond, bond order equals 1, which is the weakest of the three. O2 contains a double covalent bond, bond order equals 2, which has intermediate strength and length. N2 contains a triple covalent bond, bond order equals 3, which is exceptionally strong and short. Analyze the minimum positions, bond lengths, on the x-axis. Looking at the graph, the curve for X2 has its minimum point located furthest to the left, shortest internuclear distance. Since hydrogen has the smallest atomic size by far, X2 must be H2. The curve for Y2 has its minimum in the middle. The curve for Z2 has its minimum located furthest to the right, longest internuclear distance. Comparing N2 and O2, because nitrogen's triple bond pulls the atoms closer together than oxygen's double bond, N2 has a shorter bond length than O2. Therefore, the intermediate distance Y2 corresponds to N2 and the longest distance Z2 corresponds to O2. Correlate with the well depths, bond energy, on the y-axis to verify. Y2 has the deepest potential energy well, around -950 kilojoules per mole. This matches the extremely high bond energy of N2's triple bond. Z2 has an intermediate well depth, around -500 kilojoules per mole. This matches the moderate bond energy of O2's double bond. X2 has the shallowest well depth, around -436 kilojoules per mole. This matches the lower bond energy of H2's single bond. Select the correct match, combining these observations. X2 equals H2, Y2 equals N2, and Z2 equals O2, which corresponds to option A. The correct answer is option A, X2, H2, Y2, N2, Z2, O2.